Oh snap, we live. All right. It's one of my first live videos. Just testing this out, trying to figure out how this thing works to try to go live on all these platforms. I wasn't able to do Instagram, I don't think. So that sucks, but I'm gonna try to do this anyway the best I can. Thank you for joining. If you have joined, I don't see anybody join yet, but that's cool because I don't really care. I'm just trying to get used to doing this. What I want to do over the last few weeks, I've been going through coding challenges just to get better at it, not for any like stronger purpose than just getting better at it and just being stronger with this in my career. It's been a long time since I actually dug into data structures and algorithms. So I think now is a good time for me to really dig down. And I want to share that journey. So taking y'all on a journey with me to get better. So what I ended up finding was this thing called Grind 75, which there used to be this thing called Blind 75 from the app called Blind, where somebody came up with a list of the top 75 coding challenges to do. And then the guy made a new thing called Grind 75. It was supposed to be better 75 coding challenges to do to prep for, interviews or doing interviews for other people or whatever, helping people practice whatever your purpose is, or just getting better at data structures and algorithms so you can help your day-to-day programming. But when he made this website, it allows you to set a schedule. So how much time you need, you can set the number of weeks you have to prepare for whatever you're trying to do. And then you can set up the number of hours a day that you have in those weeks. And it'll give you, out of the 75, a week by week plan of what questions you need to do. So I set it up. I can't remember what I set it up at because I had to make the screen skinny to try to work for Instagram. But I don't know. I don't think I'm on Instagram live, so it might not matter. But let me see. Oh, yeah, I am. So cool. Oh, it's got a little delay. So I'll go out of that. But anyway, so let's start with the first one. First one's called TwoSum. I already opened it over here, but let me just reopen it so it's fresh. So this is supposed to be an easy problem that you do early in the first week in this plan. TwoSum, I've done this problem before, so this won't be just new, but doing it in this way will be new for me. We'll try to articulate my thoughts and things like that for anybody who's viewing this right now. So TwoSum, the problem goes like this. The description itself is like this. Given an array of integers, nums, and an integer target, return the indices of the two numbers such that they add up to the target. So given an array of integers, nums, and an integer target, return the indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and that you may not use the same element twice in the solution. You can return the answer in any order. So an example they give here is a list of nums 2, 7, 11, and 15, and then the target is 9, and the output is 0 and 1. So the index 0 is 2, and the index 1 is 7. 2 plus 7 equals 9. So that makes sense because nums, equal 9. We return 0, 9. This example, 1 and 2, 2 and 4, 2 plus 4 equals 6. And that's how you get that answer. There's some constraints down here. Greater than 2. So the list of nums is always going to be greater than 2. And then the nums is going to be less than, it's going to be in between negative 10 to the 9th power and 10 to the 9th power, and the target is going to be the same exact thing. Only one valid answer exists. And the follow-up, can you come up with a solution that, why did this do this? Can you come up with a solution that's less than big O of n squared complexity? It's got kind of weird. Hold on. Let me refresh this. Okay, cool. Okay, so looking at this, I think the first thing I would look with this problem just kind of like validate that, like, my assumptions about the problem, make sure I understand it. It's a list of nums, and I need to find the two elements in the nums list of nums that add up to the target. And it'll only be 2, and there's only one answer in the list. And there has to be 2 or more values in the list of nums. So some of the things I would ask about, like, is like the constraints that they already gave. Like, will there always be enough values in nums? Will the inputs be like numbers that can't be processed correctly because of like memory within the system? Like the numbers are too large to be, for memory to actually run them, which it doesn't seem to be the case based off the values here. And then only one value exists. So like, what do I return if there isn't any answer? But it looks like there'll always be an answer. I mean, this is kind of what this is assuming. It doesn't explicitly say that. So I'd probably ask, if I was interviewing or something, like, does this mean that there's only one answer? So anyway, get into the solutioning. I've done this before, but I think my process when I was thinking through this was like, when I first was early on, was like, okay, in order to know which ones add together, just being a programmer, I know I can do a loop. So I know I could loop through this array. And I know I could loop through this array multiple times. So I feel like I need to know, I could add each of these numbers together, the combinations together, and see which one equals 9, and then return the indexes of each one. So I could like loop through and get to 2, and then I could stop at 2 and loop through the rest of these and add them together at each step and see which one equals to 9. And I can go to 7, and I can look at all of these and see which one equals to 9. And I can stop when I get one that equals to 9, that's a brute force solution is what it's called. I'm going through everything, and then every time I stop at one of these, I'm looping through the array again for each one to check if you add the other two, the first one that I'm at in the iteration of the loop, if it equals to 9. Like I said, that's like a brute force solution. Because I'm going through the array one time, and then for each time I'm looping through the array again each time, it's n squared in time complexity, because it's n times n number of times that I would have to loop through this to check not only each one of these, but then check the whole array each time for each one of these. So it's n times n times that I have to go through it, which is if you know, which maybe I'll do another video on that, or another live on like a big O notation. But that, I guess that's why they're asking that here, and I'm pretty sure that's why they're asking that here. Can you do this in less than big O of n squared time? Which is not really most acceptable in most interviews, code that you write for applications, anything you're doing. Like, this will just be exponential time complexity. It's big when n gets bigger, the worse your algorithm is going to be and perform. So as I've learned about this problem, I didn't just come to the solution myself, but as I practice this problem, I learned that you can trade space complexity to help reduce the time complexity and get them both to a acceptable number. So what I mean by using space, what I can do is I can go through this loop once. And I mean, I guess I can take a step back. The main thing you want to think about is the trick here for this problem is looking at the what's the word? Looking at the I can't think of the word, but basically looking at each number, what it takes to get to 9. So at 2, 9 minus 2 is 7. The complement, that's the word, the complement. You're looking at what complements 2 to get to 9. What complements 7 to get to 9? 9 minus 7 is 2. What complements 11 to get to 9? Minus 2. Subtracting 2 from 11 gets to 9. What gets to 9 from 15? Subtracting 6. So if you think about complements at each step, you could actually just loop through this once and calculate the complement. So when you get to 2, 9 minus 2 is 7. When you get to 7, 9 minus 7 is 2. When you get to 11, 11 minus 9 is, or 11 minus 9 is negative 2. So what you can do is when you get to each one, you could actually just store the complement in a object or map or some sort of data structure that you're able to do fast lookups in that don't take away your time complexity. And that's like a hash map or an object that you can look up in constant time. It's like big O of 1 or big O of constant time or whatever they call it. So you're going to actually use more space in like data storage in the runtime of the algorithm, but that's gonna help you with reducing, so you don't get this n squared amount of time, by reducing your time complexity and using up space. So I want to try to jump into this. This is something I haven't done before on here, but I'm going to try to do it. It should be an easy problem, but under pressure, easy things can become difficult. So I'm going to try that solution out. And what I said before is that I'm going to find the complements and store them in the map. And the one thing I didn't get to when I was talking about the solution was that once you store the complements in the map, then when you get to the next, as you're looping through, when you get to one, you can calculate the complement and see if it's in your map already and store the index to whatever was in your map. And then you can basically say, okay, if I already have the complement to 11 in my map, or in this case 7 in my map already, as in 2, then I know that the complement plus 7 equals 9, and I know I found my two indexes that I need to return. So you would say 2, 9 minus 2 is 7, that's the complement. And so then in that case, I would store, I would basically store you could store the complement, or you could store you could actually just store the value in there, honestly. But some people like to go and store the complement in there, and then they like to compare the complement to the number that they have here, and then go back and look at it. But you can pretty much do it either way. You can I like to do it the other way, compare the complement to a previous value that I've seen before. And because I'm storing the index of the complement in the hash map, then I can easily go back and find it really easy, or fast, actually, in big O of 1 constant time. So I want to try that out. So what I would start with is a map. I don't know if I can I just call it a map? Compliments. I'm just gonna call this compliments. This is where I'm gonna store the compliments. In JavaScript, there's a map. You can create a map. There's a data structure, like a specific data structure for it that gives you some advantages over using an object. You could just use an object here. So I'm gonna do that. I always like to start or very close to starting with like, what is my return, even if I don't have it yet. Like I know I need to return an array of something. And in this case, I should never get to this, but I like to just return it, so I just always clear up what I'm returning. And then, like I said, I'm going to loop through basically one time each value in nums. So this is like a for loop. And for each number in there, I want to basically calculate the complement. So I can basically, if I want to just get my num, I can just get that out real quick out of I, and I can say that complement equal, so how's my complement is my target, like I said, minus num. And that's my complement. And then I can say if let me think. Yes, if my complements map has my complement, and this is why I like to do this problem this way. There's multiple ways you can do it, but it just kind of like reads easy. If it has complement, then I know that somewhere else in this array I have, like in this case, I'm at 7 maybe, and I have 2 already, which is the complement that I just calculated. And so, I can basically get out of complements, get complement. That gives me the index of that's what I plan to store, is the index of the complement. So what I would do is actually return that as part of an array, and then I would return the index that I'm at, because that's part of the answer too. Like these are what are added together to get to your target. So to get to the target, what is my index now? I. And then else, here I need to actually build the complements array. If it's not in there already and I didn't return out earlier, then I need to, I think it's add, I basically want to add the number and its index. So really these aren't complements. Really that's probably a mistake I made. Really these are like indexes. But they are complements at the same time too, because everything in the array is a potential complement. Everything in num's array is a potential complement. So misspoke. They are complements, but I didn't calculate them. They're actually just the numbers in num, but you can call them complements as well, because all of these are potential complements. So anyway, I'm adding the complement, which I'm just adding the current number and adding its index so I can maybe find it later. And so this should work. What people usually do is you want to like test your code. So I'm going to use this easy example here and run through it. And like when I test, like you want to just write everything down, because otherwise, like these are the outputs. Otherwise, it's kind of difficult to keep track of. You can keep track of it in your mind, but then, it's easy to mess up in your mind. So, and I also want to keep track of the current num and the current complement. Keep track of these, and I'm just going to walk through this myself. So I come in with nums and target. Oh yeah, I need to add target here. I mean, I guess this is not ever going to change, so, but I'm going to write there anyway. So target is 9. So I'm going to come in, make this new map. Oh yeah, I keep track of my map too. Like forgetting to keep track of all kind of stuff. Compliments. So my map's going to start out like with nothing in it. I want to show the map like an object. So compliments gets initialized. Did that. I come in through a for loop saying that starting at 0, going through the length of nums. The first num I'm going to get is at index 0, so I'm going to have num is going to be equal to 2, and I guess I can put index in here too. It's a lot of stuff to keep track of in here. So I can say my index is 0, and I get 2 out of that. The complement that I calculate is 9 minus 2, so I get 7. And I'm basically going to say, does complements here have 7 in it? No, it doesn't. So I'm going to go here to complements, and I'm going to add the number 2, and I'm going to add its index, which is 0. I'm going to say 2, 0. And then I'm going to loop back again. I'm going to be at index 1. Number is going to be 7. And I'm going to erase complement. And going to, number is going to be 7. Complement is going to be recalculated as 9 minus 7, which equals 2. And I'm going to come into this condition and say, does complements have a key in it called complement? Complement is current, complement is 2. Yes, we do. So I'm going to return my output here. Complements get complement, which is 2. What is the value of 2? Is 0. So then I'm going to put basically 0 in here, and then also put the current index that you're at. The current index I'm at is 1. And so then I'm going to put 1 here. And does this check out with our solution? Yes, it checks out with the solution. So once I got to this point, then I probably would feel comfortable running the code, at least trying it out for a first run. And I probably check for any bugs or edge cases. I mean, you kind of find bugs while you're debugging this, but I probably look for some edge cases too. They kind of, this problem is kind of easy, so they kind of like take all the edge cases out. I feel like it has to be 2 numbers, so you don't have to check that number has something. Only one valid answer exists. Like, it doesn't even say what to return if there isn't a valid number, so it's almost like it expects it to always have a valid output. I'm sorry. And then these numbers are in a proper range that I wouldn't need to like split the input or something because it's too large for memory, which is kind of like another concept to probably learn if you haven't. So anyway, and then this never should get hit pretty much. I mean, because there should always be an answer eventually if your code is correct. So I'm going to try to run this. I don't know what it's going to look like in this tiny screen. Uh-oh. I got a bug. So you see what it is. Complements add. So I think on a map, I'm confusing a JavaScript map with a set. And so I think it's actually set in map, which is kind of confusing in JavaScript because for set, it's not set, it's add. And for map, it's set. But then you have sets in JavaScript too. So I believe that was the issue. And that's why you have to be careful and make sure you know your stuff when you go into interviews. But that was a quick fix. Luckily, I got the right answer here. I think this thing lets me put in different test cases in here. So maybe I can go ahead and put in different test case and test that out. 6. So I should get 6 for this. Run the code. Yep, I get that. I can test these. And I mean, on your own, where you're coding at a job, if you're trying to like do something where where you really care about complexity and stuff like that, and you're making unit tests, you would take all this time to do this. If your goal is like an interview or something like this, you wouldn't take this much time to do this kind of problem. Like you'd have to get like really fast on it. I mean, I'm even talking to myself. Like I'd have to be way faster than this to do this problem. I feel like I would. So yeah, I got the right answer for all three of the inputs here. And Leetcode allows you to like submit it and test it kind of against other users on Leetcode. So I'm gonna submit it. I got the screen squished for Instagram, but I think I'm gonna try to like move. Yeah. So it's faster than 80% of JavaScript online submissions. The memory usage isn't that much better than most of them, but that's okay. And it was accepted. You see my history here. So when I started, I was like, I got like even time exceeded. Like I had some kind of like crazy loop in here. Yeah, wrong as I finally got the right answer. This is like 2019. And then even last year I like tried to do this and messed it up. So it was a learning journey to even do this considerably easy problem. It's not easy if you don't do these all the time. You could be 10 years in your career, 15 years, and if you just don't do these all the time, or it's not part of your normal day-to-day work, or it's something you have to care about in your work, which there are a lot of programming jobs where you don't. I mean, I think the basic concepts of like code complexity, yeah, but like, these type of like challenges, no. So I think that's pretty much it. Thanks for watching, everybody that jumped in. I'll probably repost this to all my social media platforms, KG.codes. I'm gonna see how this goes. I may do more of these in the future. And yeah, thanks for watching. And I think I'm gonna end it here. Appreciate it.